Alright, we're going to do a video covering exponents. Exponents are often taught with a series of rules, but people always mix up those rules and they don't understand where those rules come from. And those rules actually come from a consequence of what an exponent is. So I'd like to hopefully explain that to you so that you'll have a clearer understanding, and that in the future, without any sort of refresher, you'll be able to recall how they work. So number one fact about exponents you have to know is that as a random act of kindness, they often do their dishes for their mother. True. So they're nice. They're not something to be afraid of, not intimidating. They're all right. Second thing is exponents are repeated multiplication. Exponents are a notation for repeated multiplication. So like if I had something like a to the fifth, right? That means a times itself 5 times. That's what it means. Okay? A to the fifth means this is a shortcut. It's a notation that means this. So instead of having to write out a times itself 5 times, we write this instead. Alright? A couple things. A is the base, and the exponent is 5. The exponent tells you how many times the base is being multiplied by itself. Alright, I think everybody knows that, but this is maybe the most important thing to know, because every single consequence, every rule about exponents comes from this. Alright, so first thing, most simple thing you're going to see would be something like this. Okay. Now hopefully, well, maybe you've been taught that if the bases are the same, like a, and they're multiplying, then you add the exponents. So that would give you a to the 7th. But I want you to understand why. Not so much for this rule, but for the things that get a little more complicated, well, it'll help shed some light and make it not so mysterious. So a to the 5th, of course, would be 5 a's. 1, 2, 3, 4, 5. That would be a to the 5th, right? And then multiplied by a squared would be 2 more. If you count them up, 1, 2, 3, 4, 5, 6, 7, right there, that's a to the 7th. So a to the 7th, the reason why this is true is because it's 5 of them here, 2 of them there, and they're all multiplying. Exponents are repeated multiplication. So there you have it. Now let's talk about this. If you read this, one way you could read it is actually that the base is not just a. The base in this case is actually a to the 5th. That's grouped together. Parentheses make a group. And the exponent would be 2. This 2 means that the base is multiplied by itself. Right? So there's 2 bases, there's 2 of them multiplying by themselves, and if we were to write it all out just like we did in the previous example, you would see that that is 5 plus 5 is 10. The shortcut you might have been taught would be to multiply when a power is raised to another power, you multiply those powers. But the reason why is because the base in this case is actually a to the 5th, and we have 2 of them multiplying. So that's where that rule comes from. Now let's talk about what about a situation like this? A to the 5th divided by a squared. Now, maybe you've covered this in class, maybe not, but if the bases are the same and you're dividing, then you end up doing subtraction of the exponents. 5 divided by 2 is 3. Well, here's the reason why that's true. On the top, in the numerator, we have 5 a's, and in the denominator, we have 2 a's, and they're multiplying. A divided by a is 1. It reduces to just be 1. You're doing division. And a again divided by a is 1. So what you're left with is a times a times a, which is a to the 3rd power. People don't usually have too much trouble with that, but when it would be the other way, like this, then it causes problems. That turns out that's 1 over a cubed. And the reason that is because I've got a squared on top. Yeah, let's write it this way. Let me see. A squared on top, and you can actually separate it to be like this. You see, these two things right here, there would be the same. A squared times 1, no, that's just a squared, and in the denominator, a to the 2nd power times a to the 3rd power, that would give you a to the 5th power. People I don't know, they get really confused with all this, but let's take it back to something you're familiar with. Would that be 3 over 25, right? Yeah. Thing is, we can't reduce the 3's, so let me see. What if we did it like this? What if we said it was 3 divided by 3 times 1 over 5? That would be similar to this situation right here. 3 divided by 3 is 1, and you're just left with whatever's left over. And you see how that works? A squared divided by a squared is 1, so it just reduces. So, let's move on. Let's do one more. Let's do a to the 7th divided by a to the 11th. If you wrote it out, there's 7 a's on top. I could just do that instead. And there's also 7 a's on bottom, but there's 4 more. Do you see? That would give you 11 a's. A to the 7th divided by a to the 7th is just 1. The numerator is 1 divided by a to the 4th. All right. I hope that's not too confusing for you guys, but I know we end up getting into areas where people are uncomfortable once we start making fractions, but that's where it is. Subtraction. All right, so a couple questions for you so far. First is, I'd like you to just think about these 4 questions I'm going to write on the board. If you could simplify these, what would they become? So while I'm writing them down, you take a look and you take your best guess. Okay? Now, I'll tell you for the first one, the most common answer is a to the 10th. And that's wrong. It's not correct. The reason that's not correct has to do with the order of operations. PEMDAS. If you have to do exponents before addition, you don't know what a is, so you can't cube it. And so you don't know what a is, so you can't multiply it by itself 7 times. And you would have to do both of those operations before you could add them. So this actually could not be simplified at all. That would be the answer. If you had to write down an answer, you would just rewrite a cubed plus a to the 7th. Now this one gets confusing to people. A lot of people, most common answer would be a to the 10th again. It's also wrong. It turns out there's one a to the 5th and another a to the 5th. That's 2 of them. 2a to the 5th. That's what that would be. Remember, multiplication, this 2, multiplication is repeated addition. Alright, now this one, that one is a to the 10th. There's 3 here, 7 there, and same here, 5 and 5. So, anyway, let's see how you guys are doing with all that so far. Here's what we covered. Exponents are repeated multiplication, right? So a to the 5th times a to the 10th would be a to the 15th, right? This would be 3 a to the 7ths, which if you added them all up would give you a to the 21st. This, that's supposed to be a 7, would be just plain old a to the 4th, because I've got 7 on top, 3 on the bottom, right? And that would be the same. A to the 3rd times a to the 4th would be a to the 7th, and a to the 3rd right there, and that would be over 1. Those reduce to 1, and you're just left with a to the 4th. So that's what we got so far. Now, let's talk about exponent of 1. There's an invisible exponent of 1. Always there, and that just means itself, right? No trouble, I hope. But what about this? That equals 1, and I'd like to talk about why. Also, anything to a negative exponent is the reciprocal. So let's talk about why these 3 things work. Let's start off with well, we'll use the number 2. So work with me here. 2 to the 5th. Would you agree that would be 1, 2, 3, 4, 5 2s, right? And if I were to divide that by 2, so if I were to take this and 2 to the 5th, and if I divided that by 2, then I'd end up with 2 to the 4th, right? 1, 2, 3, 4. This will tie in just a minute, you'll see. Now if I divided that again by 2, I'd get 2 cubed, right? So this would be 2 to the 4th over 2. That's what I'm going to write right here, right? So that would be 1, 2, 3. Now if I took this, 2 to the 3rd, and I divided it by 2 again, so if I divided it by 2 again, I'd get 2 squared. Do you see? 2 times 2. Now if I took this and I divided by 2 again, I get 2 to the 1, which is 2, right? Now if I divide it by 2 again, 2 divided by 2 is 1. And you see how the exponents are going 5, 4, 3, 2, 1, 0. Right? Every time I go down by an exponent, one value, then I'm in essence dividing both sides by 2, right? So 2 to the 1 power divided by 2 would give me 2 to the 0, and that's 1. I could do this with any number. I could do 5 squared would be 5 times 5, right? And if I were to divide that by 5, both sides, right? I get 5 to the 1, which is 5. And if I divided both sides of that by 5, I get 5 to the 0, which is 1. Anything to the power of 1, anything to the power of 0 is 1. It doesn't matter what it is, always. And that's why. Now let's keep going with this. What if I continued and I divided by 0? Here's 1/2, right? But what would the exponent be? 5, 4, 3, 2, 1, 0, negative 1. And if I were to take this and divide by 2 again, now let's be really careful right here. The way you divide is you multiply by the reciprocal. So this thing right here would actually be 1/2 times 1/2. And since we're using exponents, let's not write 1/4, let's use an exponent. That'd be 2 to the negative 2. Do you see? One more time. What if I went ahead and divided by 1/2 again, remembering that dividing by 1/2 is the same, divided by 2 again, I misspoke. I'm going to take this, divide by 2, remembering that dividing by 2 is the same as multiplying by 1/2. Do you see the repeated multiplication right here? 2 to the negative 3rd would be 1 over 2 cubed. Now, we're going to get into this stuff a little bit in greater detail in a little while, but here's the thing. A negative sign means the opposite. Exponents are repeated multiplication, right? So this would be 5a's multiplying. Exponents are repeated multiplication. Negative means opposite. This is repeated division. This would be 1 divided by a 5 times, or 1 over a to the 5th. Negative exponents give you reciprocals, because when you read it like this, you're dividing, and this is the opposite of repeated multiplication, which is repeated addition. Repeated division. So anyway, this is a long video. It was quick. Covered a lot of material. Hope it made sense. We'll get into greater detail with each of these and do some practice problems in future videos. But until then, I hope it was helpful. If you found it helpful, please like, and you can subscribe. You can also ask questions in the comments box, and I'll respond. And good luck.